and we will be talking about a couple things. I'm not going to spend too much time on this because it's so damn complex. Like, what? Oh, okay. Hi, Nick. Yeah, he doesn't need a microphone.
Hi. Nice to see you, Kat. Thank you.
Can you see out of those?
Yes.
Oh, cool.
Yeah, they're just like a polarized.
Oh, I see what you're saying. So they're just sunglasses.
Yeah.
Yeah. Yeah.
This is like a wrap.
Yeah.
You notice, you'll see here. Where?
Okay. Ah, yeah. Like shutter shades.
What? That spooky eyes. Yeah.
Cool.
Thanks.
So here's a little pop quiz while we wait for everybody to show up.
No.
What are all these?
What's this? You can guess these.
Is it multiple choice?
I heard Josh say the right answer.
Crystal?
Yes.
What did you say?
He said a crystal.
Which, are you sure?
Actually, I believe that's an oscillator.
Oh, wow.
I will have to look at the schematic, but that's why you're here, right?
Yay! Wow.
Hey! Cool stuff.
Kyle, this does not prove that Kyle is cooler than me in any sort of way, just so that really? I'm talking to nothing. This election was rigged. It was rigged. My microphone wasn't open.
Josh, can you see the document camera as well as my face? God damn it.
I'm sorry.
Yeah, I know.
Sorry.
Okay, so can you see the document camera and me on Discord? I can only see it after. All right. There's high voltage circuitry in here. If I have a power cable nearby, I can zap you.
Yeah, but you don't, do you?
I do.
Oh,
It's a standard
it's not
IEC
okay.
connector. Hello.
Hi, welcome.
Hello, welcome.
Hello, Sam. I saw what you said on Discord. I appreciate it. My constituents, I'm glad that
There we go.
Okay,
So
so
this is what's visible on Discord.
okay, so that's okay. Got it.
Yeah, I'm literally just sharing that screen.
Got it. Got it. Excellent.
And we're recording, so.
Oh, we are.
Yeah.
Currently.
Yeah.
We
I
may
just
need to-
always started early so I don't forget.
Yeah. I think we should probably give, I don't know, 5 more minutes.
Oh, yeah.
Something like that for everybody to show up.
And I'll check the door once more before we get started.
Yeah. I'll definitely wait
check
for you to get back.
downstairs too. Might be a good idea.
Yeah, I think he's gonna do that. I think he's watching the door. So the schematic portion of this is courtesy of Megan requesting it when we were talking about the pinball machine downstairs.
That's schematics for that down there.
Yeah, we are.
That's cool.
Yeah, and I decided to bring a little bit more of a conventional schematic system here.
Yeah.
And besides, Tektronix really does a great job of documenting their stuff. Not so much anymore. They used to.
Back when they existed.
Well, I'm gonna run downstairs.
All right.
By the time we get back, we should be ready to get started. I guess.
Yeah, sounds good to me.
I'll walk this time instead of run.
Yes. So before that, does anybody have any questions that I can answer right away?
When's lunch break? No.
Sit down and shut up.
It's all right. Yes, Mr. Winborn. That's Dr. Winborn. That's good.
Hey, if you guys want to take a break real quick, get what you need, that's fine too.
Food.
So
My knuckle.
that's what you get, Nick.
Shut up, Kyle.
All right, so let me ask you guys this. Megan's not here, but I want to kind of get everybody's opinion, But should we start with the digital oscilloscope or take a look at something a little older first?
Ooh, let's go older to newer.
Okay, what do you think?
I agree with
Yeah, same.
Okay, so you guys want to see the vacuum tube stuff?
Already made
Great.
a good decision.
Good
as president.
stuff, good stuff. And that reminds me, don't forget that today is the election, so please send out your votes.
Please vote.
Yeah,
Vote whichever way you feel.
yeah, so
works.
just, has everybody here voted?
Sam, have you voted?
Have you voted? It's on
Sending
Discord.
a secret. It's
Not yet.
Okay, so it's on Discord.
on this. Yeah, it's underneath the. What?
Your check isn't cleared yet.
Why did you say?
Okay, so, yeah, I think that will work well. This actually has a little bit of a more simple, easier to understand schematic anyway, so I think that's a good way to start off. Now, I think I should kind of, while we're going through it, I'm gonna, give you guys a little bit of an idea of how vacuum tubes work.
I real quick want to say something specifically about like a weird bug I just got with the Google Doodle thing.
That's a good bug.
That's a really interesting bug. It's just gone straight to the Google page.
Are you sure that's a bug?
Doodles. Yes, it is, because it would just show the regular like Google logo.
Well, let's
I don't
check
know
it
why
out.
it's doing this.
Let's try this out.
I don't know how it
See
just
if
happened, but let me refresh. Not
Google.com.
Refresh.
Yeah,
It
that's
just-
a bug.
Yep.
Cool.
Let's go. Bug hunt.
All right. So yeah, has anyone here ever messed around with vacuum tubes? Most of you guys are still alive or not singed, so I imagine you guys have not. They can be pretty dangerous if you're not careful. Everybody knows who it is, Nick.
I know. I just wanted to make sure they know.
Righto. So I think there's a way to walk.
Oh
this.
no. Good. I'm done. I'm not gonna do it again.
Well, I know, but I've accidentally bumped it before.
Oh, okay, that makes sense.
I was just, oh, whoops, wrong one. That's what I meant. I was just, thinking because, yeah, it's kind of fun, not,
Having your lecture interrupted.
yeah, exactly. All right, I think it's,
It's just about time. I don't know if Josh is coming back.
okay, and here's another question. How many of you have ever soldered before?
A little bit a while back.
My dad has experience in that. I think he has his own like soldering iron.
Yeah.
I think he has his own.
Okay, so I'm not sure.
Soldered or soldered well?
Fair enough. Okay, let me rephrase. Who has held a soldering iron?
A long time ago.
Okay, because there's going to be two parts of this. We're not going to spend a whole bunch of time on the second part. Just kind of walk it through the procedure, and it's actually a hands-on portion, so that'll be fun, I hope. Or it'll be horrible, and everyone will catch on fire and blame me.
Yeah.
But we will see how it goes.
Which will then raise my standing as a CF. I'm done. All right. I gotta
So
stop.
anyway, we will definitely spend most of the time with the schematics and stuff like that. But I think we will finish pretty quickly still. I mean, there's quite a bit to cover, but I'm not gonna like try to inundate you guys with information because there's so much just to talk about on this board that is on screen right now, and there's a board on this side, there's a board underneath here, there's a board underneath that, there's a high voltage section, and of course, the main motherboard on the bottom. Oh, and one back here. Behind the front panel, so. Yeah, quite a bit of stuff to talk about just with this alone, so I'm not going to get stuck in the weeds there. Hey, Josh.
No one there?
Megan's heating up some food, so we're gonna give her a chance to return.
That sounds good.
Yes.
And I was also thinking for the elections thing, maybe it would be cool to like, since today's the elections, have you guys talk for like 60 seconds or whatever about what you want to do for
Yes.
ACM, each of the different candidates.
Yeah, that's fine.
That's fair.
I mean, I'm okay with
Yeah,
that.
definitely.
Right. So what you can do is I'll just have you hit, like when you go Kyle, I'll have you hit the instructor cam, and then Nick, you can hit your cam.
Oh, wow.
And
But I don't have a
zoom in on
personal
you,
microphone?
And we'll have, we'll have zoom in on Megan. That way.
But I don't have a personal microphone. You can my full. Wow.
Well, you get
They're already
the main
stacked
microphone
against
right
me.
there.
Odds are already stacked against me.
May the best Kyle win.
The best Kyle wins.
Ouch.
Truly. Let it be known that I voted for my constituent out of the goodness of my heart, showing my
I believe you
character.
mean competitor. Not a constituent yet. Hey, welcome back.
Yeah.
All right. So I will ask again. I will ask because we had. Let's see. Is there anyone online?
I don't think so.
No. Aw. Okay, that's fine.
No one online.
I asked Joey if he would join, but he said that he's got more. He said he would need a divine intervention to get done with all the work that he needs to before.
Yeah, that's adulthood.
Let us all
Thoughts go
pray.
out to Joey.
Yes. Okay.
I talked
So
about Joey
here
for
we
this
go.
meeting.
Let's start this over. Now.
We started the recording.
Yeah, it's going.
Okay, cool.
So, Megan, would you prefer to look at this one or this one first? The older one with the vacuum tubes or the big old digital scope? Which one would you prefer to start with?
Well,
Okay.
before we start, do we want to do the?
We will, but I just want to,
Sure. Yeah.
and you, what do you think? Same thing?
What?
Start with the vacuum tubes?
That'd be cool.
Okay, so that looks like it's unanimous. Have you ever held a soldering iron?
Yes.
Okay, and I know you have. I sure would hope so, working at GE. All right, so, yeah, I think that we can get started.
Right.
What are you doing?
What am I doing?
Yeah, what are you gonna be doing?
Well, I'm just gonna be sitting here, but what I'll do is I'll get up here, I guess. I'll sit at the thing and get in front of the camera
All right.
and hit the whatever.
So, are we actually we're doing this?
Yeah.
separate- to everyone on the camera that is there.
Well, no, it's recording. I don't know.
Yeah.
So we got 4 candidates running. We got Kyle running for everything. We got chair. So the positions are chair, co-chair, and treasurer/secretary.
I can bring up who's running for each if you want me to.
Go ahead. Oh no, I remember. But Kyle's running for everything. Nick's running for everything. Megan's running for co-chair, and Esteban's running for treasurer/secretary.
Yes.
So Esteban is not here right now, but I'm gonna have, I guess, Kyle goes and say what he would want to do as, chair, and what you would want to do as chair, and what you would want to do as co-chair. Your vision for ACM, how you would like to help, and why you qualified to help, I guess. So I'll let Kyle go first.
Okay.
And then when you're ready, you can. When he's finished, you can hit your button. And then you can hit her button, and go from there.
All right, my name is Kyle Winborn, and I'm running for, everything. And one of the things that I want to see happen is I want to be able to get more people interested in ACM. I think that we have a very important mission, not only as outreach to the computer sciences and computer engineering fields, but we also have a lot to share with one another who are already in a field like that. So I'd like to, if I were to win, I would like to expand our membership and outreach to make sure that, our chapter is successful for years to come. Thank you.
So just hit the button.
Next victim.
Oh boy. Hi there. Hi there. I'm Alexander Ndapalo, as you may know me. My true name technically I go by is Nick. I'm running for ACM president, ACM co-chair, ACM treasurer, the whole shebang. My whole plan specifically with ACM is to hopefully expand our reach with many of our projects. Like I want to start doing a lot more projects, like building this, that, and the other thing. Maybe getting in touch specifically with the president of our program to possibly touch on his projects he has on main campus and maybe get in touch with them and try and get stuff working. Like the sports, the one program he talked about during that meeting where it's like a sports thing and it determines based on the data, how people should train in sports and stuff like that. I want to try and get more people into the program, especially get more people excited about coming to the ACM meetings. I feel like the ACM meetings should have it should be a little bit more grander and a little bit more, much more attendance as well. And I feel like as well, I want to try and like get the Sun Labs like more things, update the Sun Lab, allow it to like be used more as because we need to invite more people into there, and I feel like it needs to be more like warm and kind of bringing in freshmen and sophomores and everyone of the like. And that's really it, I think. I kind of rambled on there, but hey, we got there eventually.
Okay. I don't think I have. What?
Megan has the floor.
Four.
Okay. Is this good enough?
Try hit it again. See. There we go. Okay. Oh,
Nope.
Oh, okay.
No.
Okay.
All right,
that works.
Okay, close enough.
If you want to, you can move to the one next to you, but you
Okay,
can go
that's
from there if you want.
Well, I just came into the program last year, and I'm excited about what we will get to do, especially since I was joining virtually before. But I want to help with reaching out to other people, and I think since I just came into the program, I think it'd be easier for me to reach out to other new additions to the program. And I also want to help with any additions with running the Sun Lab or getting more people to come there too. So I'll really just assist with whatever the chair is focused on.
Sounds good. All right. Thanks, guys. I think what we'll do is maybe we'll just leave the voting open all weekend, and then after Sunday midnight, and call it.
Oh yeah.
Yeah.
Good
Does that
idea.
sound good to you guys?
Yeah, sounds good to me.
All right, sounds good. So hit the dot cam.
Yep.
And you should be good.
All right, everybody, welcome to my talk on schematic reading and workshop on soldering. Right now, we're looking at a Tektronix 2440. This is actually the video section. We're going to be taking a look at this shortly. But first thing we're going to be doing is taking a look at this beauty. Let me just kind of rearrange here. Get that laser light going. There we go. All right, so this is a part out of a Tektronix 555 oscilloscope. Hey Josh, is there a way that I can share a picture
Is it? Yeah. Where's it at?
on Google?
Yeah, you can pull it up on that camera, and then if you pull it up on screen on your left screen, you can drag it over to your right screen, and it'll share it.
Oh, great. Okay. Tektronix 555. Now I'm just going to show a picture of what I am talking about, the specific scope that I am referring to. And as a matter of fact, this guy does a very good job of covering it. So like what? Do I just do this?
Yep. Just bring it over to the. Well, if you
Minimize
open
the
it-
camera,
yeah,
I
there you
think,
go.
first.
I see. Okay, so it's just, okay. Okay, so you could, well, all right, so that's
There
it.
we go.
Yeah, there it is. I have one of these at home. As a matter of fact, the guy's website, I've actually spoken to him. That's the one that I was talking to him about with the cable. He got rid of his because he couldn't find the cable. Cable on this is kind of hard to find. That's besides the point. So as you can see down here, it has kind of what looks like that, right? Right. So it takes two plugins on the bottom here, and it right here it takes the time base units. Is that visible on Discord?
Should be.
Okay. All right. And as you can see right here, this is what it looks like without that stuff. That's where this plugs in. So this would be the bottom left, right? That's actually the bay that this specific one was plugged into mine. I took this out today. And by the way, that's the delay line I was talking to you about, Josh.
Oh.
Yeah, it's horrible. Incidentally, this is the section that's right here. This is the section that I'm doing a lot of work in. It's high voltage section. It's the post accelerator for the CRT. That's besides the point, outside the scope of what I'm trying to talk about. All right. So now this is a type G plug-in unit. So basically what this is the input section. Okay. So it allows you to actually do a little bit of math. So say you have a DC coupling, meaning that there's a capacitor in line. So basically just, I'm sorry, other way around. It's shorting the AC to ground so that it only passes the DC, right? So on this side, the AC coupling this puts a capacitor in line with the inputs here. And this is just a standard BNC. This is a later model of this one. They had, I think they're called VHF or UHF, some sort of old RCA-like jack. As a matter of fact, RCA cables fit in them. But again, outside the scope. So let's go ahead and take a look at the top. This is what a vacuum tube looks like. If nobody has seen that before, that's what they look like. Okay, they're not super fragile. They're just glass, you know, just like a light bulb. Inside, there are. This one's pretty dirty, so I'm not sure if you'll be able to see it. But inside, there are little wires in there. Yeah, you can. Look at that.
What?
Camera, man.
Yeah, no kidding.
That's awesome.
So you can actually see how like this is put together. You see how this comes in and it's connected here, and this is bonded in, and this is completely vacuumed. You know, there's nothing in here but, well, there's little bits of air, but you know, there's no
It's not a perfect vacuum.
And that brings me to what this shiny part on the top here is. That's called a getter. It's a compound that they flash in that absorbs impurities, stuff like that. And if this is white, or if it's chocolate brown or something like that, that's a bad sign. It should be nice and silver like that. Looks good. So this is actually a pretty good tube. This one is a Westinghouse tube. As you can see, this stuff is just like chalk at this point. This is like over, let's see, this was a scope made in, this is probably from, I'd probably say 60 something, 64 maybe.
Wow.
So this has been in there. Who knows if this has ever been changed? Probably has, because this was actually, this specific unit was owned by NASA at one point. And as you can see, that's what the sockets look like, right? So you see how there's one missing pin on this side? There's matching here. So you just kind of do that and get a little wiggle, and there it goes.
Or a chunk.
Well, that's actually,
Oh.
it's literally just little fingers in there. So let's go ahead and take a look at the underside. We will, after this, we'll take a look at the schematics. So we got all sorts of stuff going on here. I mean, just look at that. That looks like a mess. I mean,
A beautiful mess.
I'll tell you what though, I have seen much, much worse. Oh no,
Oh no. So,
there's
technical
the
difficulties.
there's the tube tag. So yeah, that's actually that was checked. So yeah, I have to keep on to that. That's pretty cool. So they just put that on the tube to basically verify that it's been checked,
Huh.
that it works.
Just fell out of nowhere.
I believe it was on the tube that I took out. All right, so this here is the manual for this. Okay, so this is everything that you need to know to run it, to maintain it, and repair it if need be. This has all sorts of goodies in here, and it's wonderfully illustrated. All Tektronix manuals of this age look kind of like this. I love the layout. So as you can see, it's got section 1 specifications. So like, you know, what this specific thing can do, you know, the selling points. Then you get the operating instructions, you know, how to use it, you know. Then you get the circuit descriptions, which is invaluable. Very, very good stuff. I will be making a copy of this manual available to you guys through Discord. So if you guys want to just take a look through it. Yeah, these old tech manuals, great resources for learning about electronics. They really did gild the lily, so to speak, about making sure that the things that they made were well supported. So, and honestly, these are great for just learning about oscilloscopes in general because, I mean, look at that, it's just wonderful. Exactly. So this is the circuit description. This is literally the, somebody wrote down what they were doing with what part. And this is one of the reasons why I brought these manuals and these parts, because they are phenomenally documented. So you got the input connectors. I mean, they've documented the input connectors. They're just BNC jacks. That's a paragraph about that and how that circuit works. You know, the maintenance, component replacement, how to solder, like how to solder these little ceramic things. If you do it wrong, there's a little solder bonded to the ceramic that can actually come apart. So that's why that's in there. So if you look right here, and stuff like this. Incidentally, that's a great tip that we'll talk about later. This is actually using pliers as a heat sink to protect a plastic coil form while you're soldering to it. Yeah. So let's take a look at the schematics. They're pretty simple and they are beautifully done. Full color. Very nice. So we're going to start with the input jacks, which is, do you guys want to do A or B? Doesn't matter.
Hey, no, rush B. Let's go rush B.
All right, so we're going to start with the top one here. This is A, and it's this one. So it's going to be on the left of me, right of me when it's facing me. Okay, so we'll continue looking at that in a moment. We'll zoom in, take a look at these schematics. Okay.
Enhance.
All right. So here we go. Say we have a probe. We're putting it in here. Right. There's the input. Okay. So that's what the little circle in the thing. Give me a second. There we go. Now it won't try to wig out with my hand. All right. So your input A. There's the little jack, and you can see there's a circle and that little circle in the middle. What that means is it's a coaxial connector. Okay, so the outside of the BNC. Does anyone know what the symbol means?
Ground.
Yep, that's ground.
Yeah.
So that means that the output or the outside, this little metal part, the metal jacket here, is connected directly to ground. Okay. Now we go in through this capacitor. And as you can see, that's that blocking capacitor that I was talking about. Okay. And if we look on okay, that's that guy, that big old bag.
Wow.
I almost cursed.
Chunky.
I caught myself.
Good boy.
All right, but yeah, this actually needs replaced for different reasons. I think I talked about it in my my passive components lecture, but basically it's just old. And what the idea of this is to stop DC from getting from the inputs to the circuit back here. And if it's leaking DC, it's not doing that, right? So basically it's just not doing its job. So I had to test those, but that's basically, I'm going to replace them anyway. The value there is not really important. I mean, it is, but you know, it's not super critical.
Why does it say they're deleted S/N?
Well, because they actually added this part. That's a good point, because what this is, if you look, actually, there's a second set of schematics here. And you notice
That's not deleted.
that is not deleted. That was in red in this one. See it right there?
Were those two different
They're the same model, but they're different serial numbers. So this is actually a newer batch of the same stuff. So this one is actually the serial number on this one. If you can see that, I'm not sure if you can. Let me focus on that. You can see it's 9847. Okay, so that means, and I sure hope this is the case, that we all know that 9847 is greater than 1584. You know, I think that's a pretty safe bet in this room. So yeah, so that means that this was a revision that they added on newer models, specifically ones that made, specifically the first one that they did that on was 1584.
Interesting. Got it.
Right.
That's why it says up.
Yeah, yeah, but they also did include the original schematics, which I think is phenomenal.
That's really neat.
Yeah. So as a matter of fact, I'll just knock over my stuff. Don't worry. You actually look right here.
Preamplifier.
Yeah. So that's what this is. That's a preamplifier and SN serial number 101 to 1000. And then you look at this one, serial number 1001 and up. Okay. So these are actually, this is another revision of this. And these red are revisions as well. So then now, okay, so basically, if we look here, this looks quite intimidating to look at, doesn't it?
Yeah.
Like, what the hell's going on here? Well, it's just this
You
switch.
used to swear.
It's this switch right here. It's one of these. Yeah, it's this switch. This switch right here.
Oh.
So that's just your selector. So you can tell because it says AC and DC, right? And if you look on the switch, sorry about the bad focus, but that says AC and that says DC. Okay, not sure if you can't really make that out, can you?
Yeah.
You kind of get the idea.
Yeah.
So then after that, basically this is, these are ganged together, which that's what that giant line here means. That means that when you turn the knob here, it's turning both of those switches. Because what it is it's actually got, you see that? There's two of these wiper guys.
Wow.
So when you turn that shaft in here, it's actually turning. I'm not sure if you can see that.
I see
Can you
it
see
now.
that in the bottom there?
Yeah, a little bit,
Yeah. Let me see if I can get a light there.
But if you try to do the autofocus thing again, oh, there you go.
All right. See that turning?
Yeah.
Yeah, you see that down there in here where there's that little lip?
Yeah.
So basically there's another one on the other side there. I'm turning the wrong switch. Doing this blind. Yeah, so there's a lip on there and it makes contact. And that's a gang switch. And that's what those little dotted lines mean. So I just had to be, I just had to be conscious of when I'm moving my hand. Like when I move back to the schematics, I want it to be on manual focus. All right, so then we go into this, which is right here, it's labeled volts per centimeter. So that's your, like your horizontal, your vertical gain, right? So that's, specifically the one we're looking at is the switch. So you'll see that it has 20, 10, 5, 2, 1, and so forth.
That controls how many volts you're going to see per centimeter on the oscilloscope. Right?
Exactly. On the oscilloscope screen, there's going to be a grid. It's called a graticule.
Right.
And basically, like say it's at 0, right? You have your scope's trace centered at 0. 1 volt per division is what they would be called now. This is old speak for the same thing. So per centimeter means that you would actually have to use like a ruler to get up there and actually measure it. So volts per centimeter means the same thing as volts per division. It's the same thing. It's the same thing with cycles per second versus hertz.
Very much.
Now, volts per centimeter, you have your switch and same thing on the back. You got the same kind of wiper situation, right? And they're all ganged together. And on the schematics, you can see the exact same thing that I was just mentioning. They're all ganged together. So we have 1, 2, 3, 4 wipers there, okay? That's what these mean. And you can see that these all have different positions and all that stuff, okay? And if you look,
You do be running.
I believe somebody's here.
Yeah. I wonder who.
I wonder who too. So as you can see, because incidentally, this is a 2-channel oscilloscope. I should say it's not just 2-channel, it's actually dual trace, dual beam oscilloscope, which means it actually has 2, which actually means it actually has 2 oscilloscopes in one package.
Oh, I see.
So yeah, so everything's like, I believe this one, you can only do 2 per channel. So this splits the input to channel A or channel B,
Oh, okay.
or the upper or lower beam is what it's called, into.
So
So
those
the-
2 control the 2 different.
Yeah, they have 2 different inputs. Yeah. And down here, we also have the explanations for these. So let's see, C4267, it's labeled nicely. So 4267, 4247, let's see, 4067, 4087.
I think we have covered.
I think we do. So this might be channel B. That doesn't matter though. Point is that this.
He's
Hey,
made it.
Esteban.
He can finally speak for himself. the treasury. You missed
Okay,
my
so-
wonderful speech.
All right, so 4247, right here. Incidentally, this is exactly what this is for, so this fits right in there.
Oh, that's fine.
Yeah, so 4247 is, where did I see it? I just had it, right here, 4247. So as you can see, you know, this is the layout of that. And this is basically, the reason that it's sectioned off from everything else is because, you know, that's already busy enough. You know, the goal of the schematic is to communicate. It's not to, you know, confuse your friends.
Like a magic trick.
All right, so after it gets out of that switch assembly, we go in and we go into this little circuit here, which is 1/2 of a common cathode follower. So cathode follower. So right here, input cathode followers. That's what the CF means. So what that means is that this is a vacuum tube. Okay, so this is V3347, which is this guy, V3347. This is 1/2, and you can see that there's the other one, 4347, which is also nice because in Tektronix schematics, specifically this one, this will be 4, this will be 3. So now what this means is that this is that tube, and I believe that might be the one that I took the 1286 out. So this is a 6AK5, which means 6.3 volts, and there's 5 elements. Okay, so that's how that numbering system works. So 6.3 is the heater voltage. Okay, so that's what it means and what it needs to turn on. Okay, what I mean by turn on is that actually lights up and it glows, it heats up, and that's what this is. So
below that voltage, it doesn't operate like it should.
yeah, correct. Now, if you just put it on the heater, it doesn't really do anything. It just lights up. But you actually have to, that's why this one right here says 100 volts, right?
Gotcha.
That's because you're biasing it to work the way you want it to. So this is a, I believe they're called a pentode. Pentode, yeah, pentode. It's a pentode. So that's what you can see here, okay? So 1, 2, 3, 4, 5, right? So you have your cathode here, your anode here, right? Like a diode, right? Like a solid state diode. But inside here you have grids. That's what these little checkered marks are. So you have your control grid, your screen grid, and your suppressor grid, I believe, are the ones that they're called. Don't worry about remembering that. It's never going to come up. But basically, the reason that they do that is they allows them to control it in different ways. Okay. So we have literally the same one, but you know, the other way. And it goes in here. This is the actual amplifier here, right? So you actually have the input amplification happening here. So what the reason that they're doing it this is actually to for impedance reasons. So it's going to have high impedance on the input, low impedance on the output. Make sense? Okay. Yes.
What am I looking at?
You're looking at this,
The schematic for that.
the schematic for this. Yeah.
It's a part of an oscilloscope.
And
It
only unlock
is
one.
a part of this oscilloscope. Yeah. Yeah, so that's actually, I have one of these. So I just brought this and some of the documentation because it's a nice, clean schematic to look at. And it's got some great documentation. What's that?
It certainly looks organized.
Yeah, you should see the inside of it. Here, I'll show you. That's what it looks like on the inside.
Yeah,
And there's the CA plug-in, which is the standard one that came with the thing. And there's the power supply for the whole thing. Very nice. Very, very nice.
That's the power supply that goes up to 30,000 volts.
Well, no, that is, the one you're thinking of is right here.
Oh, okay.
That's the post accelerator that biases the electron tubes, the cathode ray tube. Right.
Now, this is an analog oscilloscope? Or is it-
Yeah, that one is an analog oscilloscope. The one we'll look at next is a digital one.
Oh, okay, so there are different,
Yeah.
okay.
This one specifically is a vacuum tube oscilloscope,
Oh,
which is, yeah. So that's what these little circle guys are. Those are vacuum tubes. So they just do this to basically get the impedance to where they want it. So these are
For
the
those who
input.
don't know impedance and resistance.
It's like AC resistance. You think of it like that. The input amplifiers right here. This is actually what does the amplification. So when you put in a signal here, it doesn't get amplified in this stage, right? This is literally just basically it allows it to have more power going through it. So it's more drive is what they call it. So in amplification, that's what that is. So they're more.
Meaning you have power coming in.
Yeah.
And then you are supplying additional power from another power supply.
No.
No?
You're not necessarily supplying more power. You are lowering the resistance that it takes to move, essentially. Right? I'm trying my
You're
best.
not messing with the current or the voltage or anything. You're just making it able to go through.
Actually, I believe that it increases the current.
Oh, okay, that makes more sense.
But I could be wrong about that. So please do check me on that. So,
I will keep you honest, Kyle, since I may be your co-chair.
okay, so these 12 AU6 tubes are amplifiers. Okay, you'll see now, Esteban, I'm not sure if you were here when I mentioned what the numbers mean. The 12 and the 6? No. Okay, so 12 means that's the heater voltage. Okay, what that means is the heater is, okay, so there's two different kinds of vacuum tubes. There's directly heated and indirectly heated vacuum tubes. Directly heated means that this cathode right here is actually also the heater. Or I should say that the other way around. That's connected directly across the voltage.
Do ones that are indirectly heated break faster?
Well, actually, there's reasons why. No, yes and no.
Okay.
There's reasons why vacuum tubes heaters break, and it's mostly because of the heating and cooling cycles caused by AC. So a lot of times for high reliability applications, they would recommend putting DC across it because it does the same thing. It just doesn't
change its
pulse, which causes thermal stress to form on the metal.
Oh, because the metal's expanding.
Yes, exactly. Exactly. Even though it is tungsten and it is very heat resistant, eventually it'll wear down. So yeah, basically that's, I believe these are indirectly heated, which means that there's a little coil heater wire inside of a metal sleeve. And the metal sleeve is actually what throws off the electrons. Okay, so the cathode throws off the electrons. Okay, so basically a vacuum tube works by heating up a coated, it's got a special coating on it, which is called an emissive coating. It's called, specifically, yeah, generally they're thoriated tungsten, or there's other ways they can, other coatings, but yeah, so don't chew on a vacuum tube because it probably has thorium in it, which is radioactive. It's poisonous.
There goes my weekend.
I think they also use cadmium sometimes, but regardless, my point is that they put it on there. It works a lot like a light bulb. Incidentally, it used to be called the Edison effect. Now it's known as thermionic emission. But the reason it was called the Edison effect was because during his experiments with light bulbs, he realized that he got a current on the other side of them if he added two filaments. So basically, you know, works the same way as a light bulb, but it's got an extra filament in it, which if you put a voltage on that one, it will pull electrons to it, causing a current flow. So that's how vacuum tubes will work. Yes. So they're like weird transistors. You can think of them that way. So you can basically just replace these with, specifically, you can replace them with Jfets. Okay. Jfets are
What does Jfet stand for?
junction field effect transistor.
There we go. Okay, good.
You
I know we learned. I know. I wanted to.
so Jfets, well, just FETs in general, I guess, because they're voltage controlled. BJTs are current controlled, so not really a one-to-one correspondence there. But regardless, you got your vacuum tubes here, your inputs, and you got your output amplifier, right? So it's two stages, and then you have an output cathode follower, and then it goes into the scope. the main scope for display and all this other stuff, horizontal amplification, all that stuff. That's all part of the main scope.
Wait, I'm seeing a few spots that have like inductors and stuff like that.
Yes, yes. Generally speaking, those are like right here.
Yeah.
I believe they're using this as a filter.
Oh, okay. Interesting.
Because you can use capacitors and inductors as types of filters, right?
Yes, but keep in mind that this is going to be a high frequency application
Oh, okay.
because it's an oscilloscope. And you want high frequency, let's see. Let's find out. We have the manual. Okay, so let's see, right here, frequency response, DC to 20 megahertz. So yeah, it's gonna be in the high megahertz. Well, not high megahertz, but it's gonna be in the megahertz, which isn't really that high. So somebody, that wasn't me. I didn't annotate this, so. Yeah, so what that means is it means 0 to 20 megahertz. So MC means megacycles, which means megahertz.
Ugh.
Yeah.
Can't believe it. Why don't we? You gotta go back in time and make them.
Now, this is a good time to mention what this means. So this 3 dB down point, 3 decibels down means 1/2 power. So at what frequency does the input get halved on the output, right? So that's the 3 dB down, and that's what it's measured at, generally speaking. All right, so any questions on that? Okay, so that's basically how you read the schematics on that. It was mostly talking about vacuum tubes. I kind of anticipated
Why
that.
do they usually put a capacitor in, not parallel to ground? What is it? But like, is that usually for like a filter?
Yeah, it's usually,
Capacitor to ground?
so there's 2 different kinds of capacitors. I will highlight them when we talk about this. So there's bypass capacitors and there's coupling capacitors, right? So a bypass capacitor allows you to basically shunt the AC signal to ground. A coupling capacitor, well, okay, so let's just keep them consistent, decoupling and coupling. Okay, so a coupling capacitor is in series with a circuit that blocks DC circuit current, right? DC voltage is going through it. A decoupling capacitor only allows DC through because it gives a path to ground to AC. And I'll show you that.
Okay.
And that's how when you have an oscilloscope and you switch DC and AC coupling, you're switching.
Yes.
The type of capacitor.
Exactly. You're putting the capacitor in series with your probe. Incidentally, that's why if you do that, you'll see that the probe will actually, the trace will say this is 0 volts. It'll actually jump up on DC.
So that way maybe there's like 2 capacitors going to ground in this circuit here for this op amp.
Yeah.
You have an AC, you have the AC signal from the signal generator, and then you just have a purely DC from, I think it's DC. Yeah, DC. You have purely DC, negative and positive on this side too. So that's what I was just curious about. That's interesting. Very interesting.
Well, it's not always used in that sense, but yeah, like for certain, like for instance, like oscillators and stuff, they can have them in ground, like with a tank circuit. They have an inductor and capacitor and stuff. Okay, this is why I didn't want to spend too much time on this because, dear God, this is the block diagram for the scope, right?
I want to go back to the Tektronix.
This is a Tektronix.
Oh, it's worse. Why is it so
What's
bad?
the purpose of the block diagram? What's it trying to convey?
It is conveying how everything fits together without getting lost in the details.
I'm already lost.
So basically what I did with that other schematic was that I just kind of narrated it. This is basically that, doing that, okay? So, shit.
We are pausing the stream immediately. Nothing happened. Technical difficulties.
Yeah, I spilled my Red Bull.
Spilled Red Bull.
Okay, now.
Minus 20 social credit.
So basically, yeah, that's gonna soak it in. Well, keyboard's fine. Thank you, sir.
Bigger me not.
Yeah, that's fine. That's fine. I didn't spill a bunch. It was just that it splashed. Things are going to be sticky for a while, but that's okay.
We'll clean it up.
I'm going to get some water. Go ahead and continue talking.
I think that's where Esteban went. What's that?
Other lights around here?
I sworn we had some
I
disinfectant.
probably do.
I think
They're
in
in-
the other room.
They're in the lab. They're in the lab.
Okay.
I apologize for this little bit of a mishap, but yeah, dusty. The back of this label that's got the glue that was on there, it's all falling apart. They put that on there in the 60s.
What kind of glue?
I have no idea. It's probably toxic. I wouldn't
What's
want
toxic?
the glue on the back of this. It's not like a stamp.
Can I give a quick tip?
Yeah, go ahead and give it a lick.
Just a quick lick will do.
There, I got it.
He's already beating me in presidential. Ah, he just opens it.
Modern problems.
Required
Modern
phone solutions.
All right.
I'll just leave this piece of
Yeah,
paper.
I got most of it with the stuff that he brought, so that was a little extraneous, unnecessary.
It worked out.
Where did Esteban go?
Bathroom?
Oh, yeah. He took the mouse pad.
Yeah. he took
So-
the mouse pad.
So basically, to answer Josh's question, and I'll repeat this when he comes back, it's the same thing that I did. It's just, it gives you an idea of how everything fits together, right? Like, for instance, you see here, right, you get like where things, like signals are going and to and from, and where it ends up.
Because that top left block, it represents the entire drawer that you showed, that you got.
Yeah, it's a little different on this one, naturally, different technology, probably 30, 40 years or so. Yeah, no, closer to 30, probably the mid 20-year range of difference between the two. So yeah, this is gonna be a lot different than the way that it did it. Of course, it's gonna have an ADC. For those of you who don't know what that is, it's an analog to digital converter, which is actually the main event, so to speak, of this thing, the ADCs, because it's actually got its own custom. Tektronix rolled their own for this, and it's actually, the ADCs are still really, really nice. That oscilloscope that I have downstairs actually doesn't have the same quality of ADC that this guy has. It's just, they're different classes of scopes. So anyway, so basically this is the same thing that I just did. It just kind of gives you an idea of how everything works together. You're not going to be able to, repair it based on this, because you need to have schematics, because when you're looking at the board, I mean, look at this thing. Look at this. Tell me where, without like, oh, man. Without telling me, like looking at the schematics, where's the RAM? What board are you looking at?
Oh, God.
Right?
So computers sneeze on that.
What's that?
Computers sneezed on that.
Yeah, this is what computers used to look like.
Ew. That's disgusting.
Yeah.
It looks so organized, but completely in disarray at the same time.
Yeah.
Yes. Like me.
These are
These
decoupling capacitors, Nick.
Oh.
That's what these are.
Neat.
Each chip has decoupling. It's to get a line noise off of the 5-volt rail.
So you don't have-
Okay, so what we're looking at right here is actually the video board. Where is it? There is a video processor somewhere on this board. Why am I
Is
missing
that fiber optic cable right to the right?
this?
Or no, the other thing. That's like that weird. I see that type of wire all the time.
This?
Oh, that there. Yeah. Not
No.
up further.
Oh, the ribbon cable?
Yeah.
No, that's a ribbon cable.
Oh, ribbon cable. I'm down. Never mind.
No, you see those ridges? Those are wires.
Okay.
So it's actually just wires. So yeah, as you can see, you need the schematics for this in order to actually do anything with it. Unless something's like, there's like a hole in a chip, you probably figure that out yourself without looking at the schematics, like, oh yeah, that needs replaced. Incidentally, that's something that did happen. Was it these ones? Yeah, it was these ones. Had a hole blown through them. This one actually. This one had a, was it this one or is it, yeah, this one. Yeah, okay. So it was like years ago that I rebuilt this thing. So these two, they're called tantalums, right? Tantalum capacitors. That's just what the dielectric or it's not the dielectric, or something like that. I forget. Doesn't matter. Point is, they catch on fire. That's their failure mode. They catch on fire. And this one here, I replaced.
You've heard of fail safe.
No, yeah, it's failed deadly.
Catching on fire.
Failed deadly. So this is a tantalum capacitor, and the specific one that I had two of these scopes, and I pieced them together and made this one. And this one here was gone. It was fire. And I replaced it with a capacitor I had lying around. And this one went while I was standing next to it. And boy, does tantalum stink. When it catches on fire, oh my God. Anyway, I digress. That's kind of a tangent. I apologize. Let's get back to the schematics.
Okay.
Now, as you can see, this is kind of what I mean. This is comprehensive, and also the little things are bent. So, and this is actually another block diagram
Wow.
that's more in depth.
Whoa.
So one of the great things is that it says that you need an oscilloscope to test the oscilloscope. It recommends a 2440 with a 10 times probe, which is this. So you need one of these
It's
to fix
ingenious
one.
marketing. Ingenious to get them to buy two.
Exactly.
Check one and then where does
Now-
it end though?
This is one of the reasons why I wanted to bring this manual. Check this out, right? Whoa. So this is the processor board, which is,
Oh, that makes sense.
give me a second here. Let's see, what's pulling? Is it this guy? It is that guy. That's this board.
Wow.
Now, I could pop this out and wave it around like a moron, but I'm not going to. Actually, you know what? I think I will.
No. Oh no. Kyle, no.
This scope has been apart more times than I can count.
It's time to take a video of this and in like one of those political commercials where they do like the black and white of the opponent, this opponent did this. He's a part on this oscilloscope. It cool. What? Yeah. Oh, and it shows that too.
All right. So, one of the cool things about this scope is the way that it's designed. It's quite modular.
Whoa.
I didn't have a single screw to take apart.
Wow, that's
This thing is a triumph of systems engineering. I'm just saying. Now, we can actually dispose of this.
Oh no! Oh no! Oh no! We literally let me dispose of it. Take care of it.
All right. So now I can actually,
There we go.
so that's great. So in any case, if anyone's wondering why this is depopulated, it's actually an option they sold. It was for a video repair option for like TVs. So it had like a decoder for analog television. That's what that is.
Wow.
So
Is this one oscilloscope is digital, right?
yes, completely.
Ah.
So the schematic that you showed that resembles this board, is that a layout?
That is the
schematic?
actual, yeah, so that is the board.
So that's a layout schematic versus a schematic.
Yeah.
The circuit schematic.
Yes. So
Which
this
shows-
is, yeah, processor
What are
board.
each of those chips? Or at least give us like a few.
Okay, yeah. I'll just point some out, and I'll point some things out that I did on the board, like something that I actually did. All right. Okay, let's start with something fun.
Yay.
Let's start with the processor,
Woo!
the CPU.
Woo!
Now, this is actually a computer processor.
Really?
Yeah,
Huh.
it is, you can actually find the same processor chip in a Dragon 32, and anyone that's interested in vintage computing. Dragon 32s were popular in the UK. Is the MC6809. Yes,
Motorola, right? Yep.
Yes.
And then there's a Texas Instrument one.
Yes, and incidentally, this is the controller chip for the CRT.
Huh.
No, that is the GPIB board. That's the GPIB controller.
GPIB stands for General Purpose Input
Bus,
Bus. Okay.
also known as HPIB,
Oh God.
I did not know that.
Hewlett Packard.
Oh, I see.
They
Because
invented
the GPIB bus allows you to hook multiple instruments together
Yes.
and you can talk to each other.
Yes, most of the scopes will still have that.
Wow.
My power supply, I believe, has it. So that is the CPU. And this is just your standard logic. Like this is a what is that? It's a buffer.
He swore. Yeah, buffer.
Buffer, maybe a 245, 74 245. I believe that's multi.
No,
That's not a multiplexer. It's I forget. It's been so long. Let's Google it with my book.
Google. We're gonna Tektronix it.
Yes. System processor, number 1.
And it's pretty standard, like if you were to go on a co-op and you were to label, you were to be tasked with creating a
Buffers.
PCB board and then also laying it out. This is the kind of stuff that you'd be doing, you'd be with on the computer, like you'd be laying out all the labels for all the different components and things like that when you do the layout section.
Yeah.
So that the engineers who come after can keep track of this is what this chip is and this is what this resistor is.
It's a binary decoder, is that it?
Oh.
I could just look on the parts list, but I'm not gonna waste the time.
I think.
So, yeah. Okay, so I'm gonna bring attention to this. This is RAM, but this is specifically the thing that I want to talk about. This is also RAM, but this is non-volatile RAM. So it
So when
says,
it loses power, it's.
Yeah.
That's weird.
hence non-volatile SRAM on the label. They still make these, and they're like $50 a pop, and I didn't want to buy one.
Wow.
Problem that I have with these is this reason why it's in this weird case. See how it's giant?
Wow.
It's a battery pack.
Oh,
Yeah.
that's how it's not non-volatile, that's how it's non-volatile?
Yeah.
They just power it?
Well, yeah.
Really?
What?
But the stupid thing is that there's no way to replace the battery.
Oh my God.
And this battery's been long dead.
Well, yeah, what happens to this?
So it's just RAM.
Volatile.
Oh, it's just
now
RAM.
it is. Now it is. Yeah, now it's just SRAM. The thing is the problem isn't that this is storage. This is where you keep your calibration constants.
Oh no.
So this is where the scope stores its calibration settings.
So it would, so the calibration settings would get reset every time you lose power
Yeah.
in the scope.
So you need to recalibrate every time.
And that's why that's there.
So you just added that?
Yeah.
Okay.
It's it really adds
Just
a
a solder and Duracell battery to it?
It's not a Duracell. It's actually a rechargeable lithium-ion battery that I bought.
Huh.
That's the same voltage and stuff. What's that?
Yes.
Yes. It's all right. I mean, I haven't any problems with it. Now, I will say though, because these technically are not at 0 volts, this battery causes these to be over their voltage, which means that every time I turn the scope on, it gives me a warning that says self-test failed. Here's why. And it says that that's why. Because it doesn't, it's not exactly where it should be. So it's over voltage. It's not dangerous to it because it's, it's not within, it's within the tolerance, but it's just something until these completely flatten out, I'm gonna have that error.
Darn, I was gonna hook up to my SRAM a car battery and
Yeah, there you go.
keep it running.
Oh.
That way my memory will never be volatile.
I don't think that's how it's works.
Forever non-pilot.
Speaking of memory, does anybody know what these are?
Is that more RAM?
No.
Let's see what happens. Incidentally, look at the date, 1992.
Whoa.
Anyone have a guess? Venture a guess.
No, it couldn't be H2. SSDs?
No. To kind of, not really, but kind of.
So this is just ROM?
Yes.
Oh,
It's
yeah.
wrong. Oh.
What kind? Why is there a sticker on it?
I don't know.
It's UV erased.
Oh, it's called EEPROM.
Yes, erasable, programmable, read-only memory.
And the way you erase it is by putting UV light on.
Yes, we have some in the lab. When we do the soldering stuff, I will show you. It's very cool, very cool. Yeah, so this is actually where they keep the operating system. Incidentally, notice what that says.
1986.
No, that.
Oh, AMD.
AMD. Yep, these are AMD chips.
Very cool.
Yeah. And you can see that I replaced these capacitors and stuff like
If I
that.
wanted to find those chips on the schematic, how would I do that?
So you would look at the schematic, right? And you could either go, recognize that that's your system ROM, and look at the block that's labeled as a system ROM, which is over here, which is exactly what those are. That's your system ROM, your 25 or 27512s here, which holds your operating system. Or you can look at this.
So could you effectively brick your oscilloscope if you just peeled off it and shine a light on it?
What's that?
Could you effectively brick your oscilloscope if you peeled off the
Yes,
stickers?
yes, that's actually if you leave it in the sun for too long.
Good.
It will take a
I
while.
left my oscilloscope. I was using that.
It will take a while because it actually, like when they do the erasing, they actually use a special device for it. But technically speaking, you could just leave it out in the sun and eventually it'll be erased, but it'll take a while.
They're just taking my
So,
oscilloscope on a
Now,
picnic.
this specific one, I want to just kind of say that this is a great way, beautiful way to what do you call it? Words and things.
Set up a table or to show.
To
that-
show a schematic.
Yeah.
Ow. A piece of plastic. That's not the one I was looking for. This is it. Okay. So this is a lookup table, right? This is a lookup table for the part. So you see C904, right? So that's a capacitor. And where is it? On the schematic, it's at 1J. Go over here. See the letters? 1J.
Oh.
And there it is, right there, right where my finger landed. C904. And if we look right here, I believe that is it. It's not labeled, but I believe that's it. Incidentally, this is actually an older book. This one is outdated because this whole circuit was removed. This is why I put that battery in there, because as you can see, there's a battery here, and right here is BT800, which is right here. When I bought this scope, there was a jumper going from here to here, just a metal jumper.
Oh, you removed that battery.
Yep. Because they didn't change the board, they just didn't install it. Incidentally, I used the, because these have tabs, this has tabs on it, I actually just soldered the, I snipped the jumper and used that as a tie point, like a terminal tie strip, almost, on both sides, and that's how I soldered that in. So it's actually just connected to the jumper. So yeah, and same stuff. Like I said, I didn't want to spend too much time on this because it's so complex.
But things like that, where you're able to look at a certain component and everything's broken down to a grid, make it a little bit more
Yes,
simple. And
it's
you look at it section by section.
right,
rather
and
than
everything
that.
is you can see that there's little lines, right here.
Yeah.
That's system ROM, the battery, memory buffer, the processor.
Everything has its own little sections. that
Yes.
Designers put them in.
Yes, and this is invaluable. I use this all the time when I was rebuilding this thing. Same with this. The information here. The goal of schematics is to convey information. If you're doing it to look cool, I don't think that you're trying the right things. I think you should probably try, like, I don't know, motorcycles or something, because schematics are quite dry, but they are extremely informative if they are done correctly. And I just showed you 2 examples of schematics done correctly because they conveyed information. This is a lot of information. I mean, this thing is probably 1,000 pages long, I don't know, all on maintenance of this scope. Waveforms, regulators, replaceable parts lists, all this stuff. And it's diagnostics. Look at this. I mean,
Is this big schematic sticking out the edge there?
yeah, it's because they fold out.
Oh, okay. Just want to make sure it didn't like greased or something.
It did, but that's okay. Yeah, so all of this stuff, it's got manufacturer number, manufacturer part number, manufacturer code, what it is, all this other stuff. It's
You
just,
said you're gonna put these on the Discord server?
yes, I have copies of this one and also this one,
Awesome.
and they are awesome. They are,
Before we go to the workshop.
Yes.
Since Esteban's here, I was gonna let him do a minute spiel whenever you're finished to.
absolutely. I was
Yeah,
actually
yeah,
just about to
sure.
finish up. No, I'm just, forgive me for this part because it's, this manual, the bindings, a little wonky. It's a little bent right here. It's old. All right, are there any questions on schematics, electronics, anything like that? Oscilloscopes? Yes, Nick?
When is the test?
Yeah,
Yes.
we'll get 3 soldering stations set up.
Any questions? Anything to add?
What's a good
Anything?
way to learn more about schematics?
Reading.
Just read them.
Reading. I highly suggest looking at different stuff like this. Teaches you not only about electronics, but how to apply it. Because this is stuff that the engineers wrote, and it gives you their thought process. And it's like commenting your code. When you write down what you were thinking when you wrote it, you'll probably understand it later, right? Nick?
Possibly for a future idea as a lecture, I'm thinking maybe you talk about like how you troubleshoot electronic issues and where you start. Like for example, with the oscilloscope, where you started like look at it and be like, okay, it's not working. Something's wrong with it, but I don't know what. And you have all these multiple boards, and how did you isolate? How long it took would be an interesting kind of.
Yeah, I mean, I can go through the process of how I isolated problems in like the scope or in the
Or
5x5.
just like a good way, like
Just
going
as
about,
examples.
yeah, about going.
It's kind of like debugging in Eclipse, but hardware version.
Yes.
Effectively, where do you start with your troubleshooting, and where do you look at first? Stuff like that might be a good lecture.
Yeah.
For ECM.
Now, I'm finished with the lecture. If everybody's ready to do the soldering, I think Esteban needs to do his thing for why you should vote for me. I'm just gonna be sitting here reassembling.
So hit your button, and then
You
we're
need help with
recording
that?
on the laptop, and
If you want.
I'll show the video, and that'll make the video zoom in on you, and then you can give us like a minute or so spiel.
Oh, gosh. I feel like in Congress.
It's just-
Very
it's
funny.
kind of formal.
You make jokes to your speech.
The voting will be done on.
See this guy? When I put that in there, this needs to go right. See the prongs?
Right there.
Let me hold there. Say who you are, why you're running, what you want to do for ACM, and things like that.
There you go. There we go. Nice.
So, pretty much I just want to
That's
ask.
it. It's good.
That's pretty much it.
Just do this.
Why is this like cut off like that?
Because it closes up.
Oh, okay.
So, what they want to do? What he wants to do? I don't know, host some, get some ideas for like hackathons and stuff like that. So, sounds like a very simple job, right? I mean, you start off with $0, right? And if that number is any different by the end of the year, you know something went wrong. Yeah?
What if it goes up thanks
If
to
it goes up,
fundraising?
something still went wrong.
Oh, no.
That's how finance works.
Time for tax front.
So, who else is running?
I think just about Kyle and me. We're already running for co-chair, so I mean, if
What happens if we win
Sure,
everything?
no, sure. What happens if we win everything?
We're gonna find out.
Actually, you know.
At that point, I'd be
if you
more.
want it to be even funnier, do not vote for me.
This man,
Either
this man.
Kyle or Nick. Vote for either Kyle or Nick, but click every single one for each one. So one or the other.
No,
The Google
don't.
form
Just
doesn't,
do it.
the Google form
No.
doesn't work that way.
All right, we're cutting him off the air. This is ringing. He wasn't paid to say any of this. I swear. Cut the feed. Cut the feed.
Alright,
Anyways.
alright.
Or just conspire with each other and just vote.
Yeah, cut the feed. Cut the feed. We're done here. We're done here. Moving on.
Nick really wants it. Nick really wants all of them.
No, no. I will. Designate.
All right.
Alright. Who's ready for workshop?
Yeah,
If anybody wants to get a closer look at this, more than welcome to come take a look.
that's pretty cool. I would.